And right now we're ready for our interview, and we'll welcome Matt Lynch to Space Station Live today. Welcome aboard the International Space Station and into Mission Control, Matt.
Well, thank you, Kelly. It's very nice to be here with you this afternoon.
Well, we've already kind of given a preview of the experiment that you are working with and that the crew aboard the space station has been working with this week. Tell us a little bit about the experiment you're working on.
Sure. Let me give you a little bit of background to start with. Most of the liquid products that we make, they contain very, very small micron-sized particles. It helps to make the product stable. These particles are really, really small, and in fact, they're about the size of a pinhead or even smaller, and so we need microscopes to see them. But what we try to do is structure them correctly, and if they assemble themselves into these small structures, kind of weave their way through that liquid and help prevent separation, such as settling of large drops and particles that we try to put into these products. We call these assembled structures strands, and if done correctly, the strands have certain characteristics. They have a width, they have a length, and we like to maintain those strands over long, long periods of time, typically for months, for years for us. At the same time, we want to set these up and we want to keep them together. There's processes such as Brownian motion, and these are kind of those little thermal jiggles that you see where small particles tend to move. And it has the effect of basically moving all these particles around, changing the strands on us. And really we don't understand the physics behind that, and current theories are lacking. So for us, and for the community at large, it's really hard to be able to control and develop systems in predictable ways because we don't understand how to do this correctly. So in our experiments that we're doing for the ACE, we have these mixtures. They're kind of idealized particles. We keep large ones. We keep small ones together. It kind of reflects somewhat the realities of commercial mixtures that we deal with. These mixtures are placed into small cylindrical cells, and those are mounted on a microscope so we can see them. And so large and small particles can be magnified with a scope. And then we have fluorescent tags on each of them so we can look at the small ones independent of the large ones and ask how they assemble into those strands and how they move over time. So, for example, I think I have a picture here that is taken actually some laboratories at Harvard with some of our colleagues. You see green ones, which are kind of big, and red ones that are kind of small. You see the strands on the left side that are all put together, and that forms the stability kind of in our product. And so the experiments in general, what we do is we actually have an astronaut comes in and tries to randomize a sample. Inside that little cylindrical cell is a stir bar. We take the stir bar by a magnet. He moves that stir bar back and forth, and that takes the samples, breaks up all those strands that you see there, and the sample's randomized. And then what we do is we watch that structure redevelop into those strands, and we ask over time how that sample then begins to change. And so how the individual particles move, how the strands move, and that gives us the insights and the data that we need then to develop our theories.
Well, so how does microgravity make your experiment possible?
Yeah, so it's kind of critical. So let me use that same picture to kind of illustrate this for you. So on the left side is the strands after we totally mix the sample up. This was done again on Earth in gravity. You see the red and you see the green, and you see that there's a amount of material in that field of view that we can measure. And what will happen is that over about 5 minutes time frame, you see the picture on the right. And the picture on the right doesn't show much in the way of mass at all. And it's not as if we're creating or destroying mass. What's happening is that mass is settling out on us. And so if we try to measure over long time periods how these structures are evolving, I really can't do that because they are settling and making all the changes that we see in those pictures. So recall that we're looking at this or thinking about this changes over the course of days, months, years. 5 minutes on Earth, these things separate. So really microgravity is critical for us in order to do these kinds of experiments, get the data we need to develop these theories.
Well, so on Earth with gravity, if you have a can of paint or stuff, you have to mix it up really good before you go off to use it if you've let it sit for a while. What, in simple terms, are you trying to learn about these things in microgravity?
Yeah, so from our perspective, we got product designers, and what they want to do is they want to be able to choose, in a sense, those particles. Here we show them as red and green, but for us, there's a kind of a palette of things that we could use. And what one would want to do is be able to design the right palette, use the right tools, in a sense, to make that work in given products. Right now, it's kind of a trial and error process. We go through and we try to, and you can think about paints as well, but you can go through and you try to pick the right flavors, the right colors, the right sizes to make it all work right. The problem tends to be that it takes a very long time if you think of all the permutations of things that you might pick, and then you have to measure these over long periods of time. So even the paint settling example, well, you have to let the paint sit around for months to know whether or not you have something that works reasonably well. And even if you spend that time, there's no guarantee that it works. And so, really, what we're hoping to learn is basically the fundamental rules that govern the formation of these structures, how those structures change over time. And by doing so, we can make a much better directed experiment and more rational design of our products. Right? And,
So,
mhm.
so Matt, I understand you guys were on a bit of a break this week, but you have been working through a number of samples. Tell us a little bit about that.
Yeah, well, so the break is not as if there's any issues with the project per se. It turns out, and I don't know all the details honestly, but it turns out that the orientation of the station, its electrical panels that are solar panels that collect all the electricity, they have to be oriented in such a way that the antenna can actually transmit data back down to Earth. Right now, over the course of this week, they're in an orientation that then kind of prevents them from sending transmissions efficiently, at least for our facilities. So we actually, through the last number of experiments we've done, we've been doing these probably for about 3 or 4 months now, we've collected a lot of interesting data. We actually have had some really unexpected results, and it's led us to really think a lot about how we're doing our experiments, how we're doing our measurements, how our optics are set up. So the break is actually a good opportunity right now to gather all that information together, try to figure out how to make our experiments even better. I would point out that we are really the first of a number of certain experiments for the ACE program itself, and so in many ways we're trying to figure out how to make all these things work. So the break is a fantastic time to just take a good breath, make sure we get all of our measurements correct.
And what's your background? Where are you from? Where'd you go to school? Where do you work now? And how does that help get you involved in the space station research?
Well, yeah, so, it's interesting, I guess. I mean, I grew up in New England and spent a few years in high school in Virginia. And I can always remember through that time, and I don't know if you're old enough for this or not, but there was a series from Carl Sagan, who used to talk about the cosmos, billions and billions of things, and it kind of gets people interested in science. Always had an interest in science from there on, and received a degree in chemistry at Virginia Tech, PhD in chemistry from the University of Wisconsin-Madison, and my thesis background revolved around optical physics and properties of molecules and surfaces. Joined P&G about 20 years ago in research and development, but along the same lines, maintained real strong academic ties. In fact, I hold adjunct positions at Cincinnati and adjunct position in chemical engineering at University of Delaware. And what this does for you is it allows you to take otherwise really, really complicated and sophisticated problems that we deal with in an industry, and we can tie it and work it together with our academic partners. And it's through those partnerships that we had then the opportunity to work with NASA. Got introduced to NASA and got into the ACE program.
So, a legitimate question of taxpayers is what's in it for me? How can you apply your research results to benefit people here back on Earth?
Yeah, I mean, I think this is really quite simple. We as a company make products that are designed really to improve the quality of life just of ordinary people, and all the things that we're learning here help us bring more products, better products, detergents, shampoos, fabric conditioners, things like this, to increase the quality of life of those people. And I would also point out that the science that we're doing as well is very basic science, and so it helps the academe world to grow their basis of understanding of materials as well. So on both levels, I think it's great.
Well, Matt Lynch from Procter & Gamble in Cincinnati, thank you so much for joining us, principal investigator for the Advanced Colloids experiment. We wish you a lot of good luck and good data gathering with your experiment, and look forward to a progress report in the future.
Fantastic, Kelly. It was a pleasure talking to you. Thank you for your time.
Thank you.
Okay. Bye-bye.
Again, that was Matt Lynch from Procter & Gamble, who's working with the Advanced Colloid experiment aboard the International Space Station, looking at how small particles suspended in fluids that are used in our everyday lives in many different ways react in microgravity, bringing that fundamental research back to activities that can help us here on the Earth.